What are solutions? A solution is a homogeneous mixture. Homogeneous meaning uniform throughout, and mixture meaning physical combination. Solutions can also exist in many phases. Now, what are solutions made up of? All solutions are made up of multiple parts. The solute and the solvent are the main two parts. The solute, that is what is being dissolved. The solvent, that is what is doing the dissolving. And the precipitate is what is left over, or what settles at the bottom.
Alright, so next up we're going to be talking about saturability. So a saturated solution is a solution that contains the maximum amount of a solute at any given temperature. So before this threshold is reached, a solution is undersaturated, which means it just has less than the needed amount, the maximum. After a solution has become saturated and a precipitate has begun to settle, a solution is supersaturated. So next up we'll be talking about solubility. Solubility is the amount of a solute to form a saturated solution with a specific amount of a solvent at any given temperature. Factors that influence solubility include pressure, which is only for gases. Now just remember that this does not affect solids or liquids. And pressure is directly related to solubility. So if pressure goes up, so would solubility. If it goes down, the other will as well. The nature of the solute, which is polar and ionic solutes which dissolve in polar solvents. It's kind of like dissolves like, that kind of thing. Next is temperature, which is where the solubility of a solid solute increases when the temperature increases. Gaseous solutes become less soluble as temperature increases, to give you a few examples. Next, we'll talk about how to compare the solubilities of substances. So we can compare the solubility of substances by analyzing a graph. Table G in your reference packet graphs the temperature, which is on the x-axis, against the solute per 100 grams of H2O, which is on the y-axis. The points on the curve represent the amount of solute it takes to make a saturated solution at that particular temperature. It's also important to know the points below the curve are undersaturated solutions, while points above the curve would be considered supersaturated solutions. Now that we've discussed what solubility is, we can talk about solubility curves. Solubility curves are graphs of solubility versus temperature. This can be found on Table G in your reference table. To construct a solubility curve, plot the amount of solute on the y-axis and the temperature of the solution on the x-axis. One observation to make note of is that most lines on a solubility curve have a positive slope. So when you're taking a test, just keep that in mind. Now that we've gone over the basics of solubility, we can now do some sample questions. Number 1. 10 grams of NH3 at 70 degrees Celsius. Is it undersaturated, saturated, or supersaturated? Take a moment to go on your reference table, Table G, and figure out the answer. The answer is unsaturated solution, because the point falls below the NH3 curve. Number 2. Based on Table G, which compound solubility decreases most rapidly as the temperature increases? The answer is NH3, because it is the solute with the steepest declining curve. Number 3. Find the curve for KNO3. How much solute will dissolve at 20 degrees Celsius? The answer is around 35 grams of KNO3. This answer can be found by lining up the 20 degrees Celsius point on the KNO3 curve to find 35 grams of KNO3.
Moving on to concentration. Concentration of solutions can be determined in several ways. The first of which is molarity, which is the number of moles per liter of solution. The equation for this is moles divided by liters. Now it is important that if you have grams, you convert it to moles. And if the volume is given in milliliters, you convert it to liters. The units must be kept the same. Now if we look at these two solutions, the one on the left has 3 moles of solute and 1 liter of solvent. If we divide 3 moles by 1 liter, we get 3 molar. That is the concentration of that solution. On the right has 4 moles of solute and half a liter of solvent. If we divide these two, 4 moles divided by half a liter, we get 8 molar. That is the essence of how concentration works using molarity.
There are actually a multitude of ways to measure the concentration of a solution besides moles of solute over liters of solution, or molarity. All of these ways involve dividing the amount of solute over the amount of total solution. One of these alternative measurements is percent by mass. Like any percent formula, the formula for this measurement is part divided by whole times 100. The part is your grams of solute and the whole is your grams of solution. Part per million is a way to measure concentration by dividing the mass of your solute by the mass of your total solution in grams and multiplying the quotient by 1 million. Okay, let's try a quick sample question. What is the concentration in parts per million of a solution containing 0.000125 grams of solute and 16 grams of solvent? If you'd like, please pause this recording to solve the question. Did you do it? The answer is 7.81 parts per million. Okay, next up, let's talk about our colligative properties. Now, colligative properties are characteristics of a solution that change when you alter the concentration of the solution. There are 3 very important colligative properties. One of them is boiling point, the second is vapor pressure, and the third is the freezing point. Now, boiling point is directly related to molarity, which means that when you increase the concentration of a solution, the boiling point also increases. However, vapor pressure and the freezing point of the solution are inversely related to molarity. This means that as you increase the concentration of a solution, you actually decrease the vapor pressure and the freezing point. You may ask, how much does the boiling point or the freezing point of the solution change as you increase or decrease the concentration? Well, that depends entirely on the identity of the solution. Why? This is because ionic compounds dissolve into their charged constituents while covalent compounds do not. Now, when someone mentions the Van Hoff factor, they're talking about ionic compounds solely. Every ionically charged particle in an ionic compound has a Van Hoff factor of 1. So for example, an ionic compound like NaCl, which is table salt, has a Van Hoff factor of 2 because it has 2 ionically charged particles in it, Na plus and Cl minus. And the higher the Van Hoff factor, the higher of the effect that raising or lowering a solution's concentration will have on the boiling point and freezing point of that solution. You will need to know any specific formulas for calculating the change in boiling point or freezing point of a solution on the Regents exam. So don't worry any. Okay, finally let's talk about molality. That's molality, not molarity. It is the final alternative method for measuring concentration, and molality is your moles of solute divided by your kilograms of solvent. So keep that in mind. Okay, Now it's time to solve some more sample questions. Take your time solving these 3 sample questions. And again, don't be afraid to pause the video and take your time. Did you get them right?